In this problem, we have been given a sinusoidal current waveform. We are supposed to calculate the peak value of the current, its average value, frequency, and the instantaneous value at t is equal to 3 milliseconds. The general expression for the sinusoidal current waveform is given by I of t is equals to I max sin omega t. On comparing this equation with the given waveform, we can find that the peak value of the current is 20 amperes. That is, maximum value or I max is equals to 20 amperes. The given current waveform is completing one cycle in t is equals to 1 upon 100 seconds. That is, the period of the given waveform is 1 by 100 seconds. If you again go through the general expression for the sinusoidal current, we have it as I of t is equals to I maximum sin omega t. The omega, what you have in this expression, is called the angular frequency. This is given by an expression omega is equals to 2 pi t upon capital T. So if I substitute the given value of t is equals to 1 upon 100 seconds, it gives us that the frequency f is equals to 100 cycles per second. Now the frequency in cycles per second will be the reciprocal of the time period. So therefore the frequency of the current wave will be given as 1 upon 100, that is 100 cycles per second. Now for a sinusoidal alternating quantity, the average value is related to the maximum value by an expression average value is equals to 2 times maximum value divided by pi. If I substitute the maximum value of 20 amperes, we get the average value is equals to 2 into 20 divided by pi, that is equals to 12.732 amperes. Now to calculate the instantaneous value of the current at a given time t is equal to 3 milliseconds, we need to substitute t is equals to 3 into 10 to the power of minus 3 seconds in the expression for the current I of t is equals to 20 sin 2 pi 100 t. So if I substitute the value of the time given, we will be getting the instantaneous value of the current equals to 0.03289 amperes.